Record on this computer.
Recording in progress.
All right. Okay. So I'll read this problem here. Foresters use regression to predict the volume of timber in a tree using easily measured quantities such as diameter. Let y be the volume of timber in cubic feet and x be the diameter of a tree in feet measured at 3 feet above the ground level. Fine. And they give you the following equation: -30 plus 60x. So 60 is going to be your slope. -30 is going to be our y-intercept. Where the y-intercept is when x equals 0. Is a change in y over change in x. Okay. And more specifically, that's going to be the change in volume over the change in diameter. So I'll kind of leave it up to you how you explain it. But those are the things you kind of need to work with, just so you know. So I'll just give you a little bit of a hint for part A. For part B, and again, I am recording, so I'll share this recording with you guys. And then I will work this out and share the solution with you guys. I should be able to do it in class today and have it done this afternoon. For part B, predict the volume of timber for a tree of 1.5 feet. That's pretty straightforward. That's just going to be y hat equals -30 plus 60 times 1.5. And again, you can just work that out. That's pretty easy, not that hard. For part C, a report concludes that the correlation coefficient for this regression line is -0.913. That figure is clearly a typo. Explain clearly why this number must be wrong. So -9.3 means you have a negative correlation. Okay, it means you have a negative correlation. And let me hide this thing. Okay. Well, here's the thing. Negative correlation about our slope is positive, meaning that as tree diameter increases, then volume should increase. So what do you think R should be instead of -0.913? Maybe it's positive point. Yeah, exactly. So that's what you would discuss. I kind of answered it already. There's not really much more you can add to that, but that's what would be considered a valid statement. So, but part A, I'm going to let you kind of explain the 60 in a little more detail and the wire stuff in a little more detail. I'll leave that up to you guys, but you have to recognize that 60 is a slope and -30 is y-intercept. B is easy, just plug and chug. And C, a negative correlation would insinuate that if one thing goes up, the other thing goes down, or vice versa. That's not the case here, because it's pretty clear that given the slope being positive, that if the tree diameter is wider, the tree's gonna be taller, right? Or you're gonna have more tree to cut, or more wood, whatever, how you want to think of it. For number 2, so you're asked to write the regression equation, get the correlation coefficient, plot in the scatter plot, and then make a residual, and then comment on the residual. So again, this is good because if you guys forgot, I'm going to record this. So you should definitely watch this recording all throughout the next week. So I'll let this be X. I'll just be Y. And what is this? What are we dealing with anyways? We're dealing with plasma glucose, which is FPG, okay, fine. And that's monitoring your blood sugar. Okay, that makes sense because you probably don't want your blood sugar to be too high, I guess. And then another measurement made at regular medical is called HbA, which is your red blood cell counts, I guess, or percent of red blood cells. Okay. Yeah, usually you do a blood test. If you go to Kaiser, I mean, when I go to Kaiser, like they give you all these things, and I don't know what it means, but as long as it's in the reasonable level, like if my doctor doesn't email me or call me, then I'm fine, right? So anyway, they tested 18 patients 5 months after they took some class on diabetes. Okay, so you have to write the regression equation first, then get the correlation coefficient, blah blah blah. So here's how you would do it. So I'm gonna pull up my calculator in case you guys forgot. So first thing, we're going to go to the home screen, hit stat, and edit. And I'm going to go and clear these out. So clear, clear. Okay, and again, I am recording this so you guys can watch it. And I got the data in front of me. So I'm just going to type it in, kind of by brute force, 6.3, 6.4. Of course, I have an advantage. I have a laptop. Calculator's a little harder to type in, 7, 7.7, 7.9, 8.7, 9.4, 10.7, 11.2, 20.3. Actually, so 11 data points. I thought it was 18 data points, but that's okay. Oh, 20.3 is being stupid. There we go. Next up, 158, 112, 153, 134, 78, 148. And it's very boring. Just gotta do it. 172, excuse me, 145, 245. Awesome. All right. Now you have that typed in, you go back to stat. You go to calc, and you pick linreg, just so you know. So I'll let you guys do that, so you guys can practice. I'm not going to do linreg. I'm not going to, but you pick linreg. To get the correlation coefficient, you go to vars, statistics, and EQ, and you pick option 7. I'll type these up so you guys have it, but that's what you do for that one. If you want a scatter plot, then what you do is you go to second y equals, make sure plot 1 is turned on and L1, L2 are selected. If they're not, you can obviously just hit enter and you can change it. You can always hit second, like L3, for example, if you want a different list. Second one is L1. You can see L1 in blue in the top left corner of number 1. And then, of course, you just go y equals, make sure plot 1 is turned on. You can turn it off if you want, or turn it back on again. Hit graph. You're not going to see anything right now. That's because my window is not set appropriately. You can see the lowest x value is 6.3, so I'll put 0. The highest x value is about 20, so I'll put like 30. And then y is the FPG. The highest is like 200, the lowest is like 70, so I'll go from like 0 to like 250, let's say. Maybe every 25. So you see it gives you the scatter plot right there. To make the residual, what you do for the residual is always going to be your observed minus your predicted. That's going to be residual. So what you could do is you could put the regression equation in here, so you could store I think you could do this. I think if you did like x plus 1, let's say, and if you did alpha L2 or second L2, there we go, minus alpha trace y1, and if it's second table, yeah, so it gives you all those different values. For different x values. So
are those the predicted values?
That's the observed minus from the equation we had. So, or you could just kind of calculate by hand. And then what you do is that when you graph the residual, any residuals above the x-axis goes here, anything that goes below. And you do this for all, you basically do it for x from 0 to 20. And this represents y minus y hat. So you'll get something that kind of looks like this. As long as it seems random, then it's a good choice. So you want randomness from residual pot. I'll actually do it after you guys get a chance to, so you can see how it looks. Yeah.
So this is the regression. You take the regression line.
Mm-hmm.
Then you take the one of the things you put the x into that and compare it.
Right. You compare what is in the table to what's predicted. And you take the difference, and that's a residual. And more specifically, it's going to be observed minus predicted. So if the observed is higher, that means the predicted under predicted it, right? Because so.
You said you know it's good.
When yeah, if all your residuals are above the x-axis, then something, or if it has like a pattern to it, that's not a good thing. You want like good scatter to show it's random. Okay. Then number 3 is gonna be more of the same stuff. So number 3, again, you do a table. You can let this be x, let this be y. So how much is slope can decline per year? That's gonna be the slope for part B. Here again, use the calculator. What percent of observed variation, percent of adults who smoke can be explained. So when they ask for this, they want R squared. R squared will explain the variation. For part D, one of the government's national health objectives is to reduce smoking to no more than 12% of adults by 2010. Use regression to predict the percent of adults smoking in 2010. Obviously, if you're letting X, but you just plug in X equals 2010 then. There you go. Use regression equation to predict the data value outside the minimum maximum values. Yeah, if you do it outside of the minimum maximum values, like in part B, it's called an outlier. Oh, wait, sorry. No. It's called extrapolation, my bad. I'm not gonna ask that because I didn't really talk about that term with you. That means you're going beyond what the line can do. That's called extrapolation. But I want you guys practicing plugging this in your calculator. That's really what I want you guys doing today. For number 4, was the population? So they're dealing with customers' monthly credit card bills using an automated machine that folds bills, stuffs in envelopes, and steals envelopes for mailing. Are the envelopes completely sealed? Inspector choose 40 envelopes from the 1,000 stuffed each hour for visual inspection. So the population is going to be basically all the people who are customers of this credit card company, like maybe it's Bank of America or Wells Fargo or something like that. The sample obviously is going to be 40 envelopes that they're picked. And explain how you should do this correctly using some random sample. You probably should like assign a number to each of the customers, and then use a random number generator to pick the actual envelopes that you'll inspect. So that's a simple random sample. So again, I could type that up for you, so you know what that means. So what you want to do is again, assign a number each customer and use a random generator And just so you know, if we look back at our notes again, chapter 8, lecture notes. Remains a problem set, still on. There we go. So we do a random number generator. It looks like this. So you have 9 people or 9 cargo to choose from. So if you got to pick 3, you start with 7, then you go 4, then you go, they actually want to choose 4 people. So 7, 4, 8. We already did 8, so we can't do 8 again. 0 doesn't exist. And we do 3. So it means I'm going to pick Cherryport, Deloitte, Foxwood, and Sapphire. That's how random number generator works. So you assign a number, and then you use a computer to randomly spit out some numbers, and then you just go along and start picking numbers from that. So that's how that works. So that explains how to do that. Number 5, explain why the conclusion is suspect and what are the lurking variables, like what could be playing a role with this. So researchers looked at countries around the world and found a positive push between CO2 emissions and life expectancy. Therefore, carbon dioxide emissions are good for your health. Does that make sense? Breathing carbon dioxide? Probably not, right? But why would carbon dioxide emissions and life expectancy have a positive correlation? What do you guys think, Luke?
As a country has like more carbon dioxide.
Good. They're probably more industrialized. Exactly. Countries more industrialized probably have more educated people, more wealth, better hospitals, better access to healthcare. So typically it would. So I would probably say it'd be more correlated between wealth and life expectancy, perhaps. Yeah. So lurking variable would probably be wealth, I would say, for that one. So I'll let you guys kind of battle through B in that one. 6 and 7 are multiple choice questions. Remember, a stratified random sample is when you separate. Actually, I'll just show you the definitions. They're in the notes. So in your lecture notes, they explain how to do multi-stage, explain simple around how to do it. We didn't talk about clusters, so don't worry about clusters. I'm not going to test you guys on that. I don't think those are clusters. I'll have to read it more carefully. And then number 8 is asking you to kind of talk about bias, misleading, poorly worded questions. So comment on how useful each statement is. So let me do one of these for you guys. We'll do part A and I'll have you guys try the other ones. So uniformed police officer interviews a group of 20 college freshmen. She asks each one his or her name, and then if he or she has used an illegal drug in the last month. Okay. What do you think most people are going to probably say? No, even if they did, they're going to lie, right? And why are they going to lie? Because they don't want to get in trouble. They don't want to go to jail, right? I mean, now these days, with marijuana and whatnot, people probably, but if it's harder drugs, you probably lie. So anyway, I probably would say there's a response bias because it's a police officer and that's about something illegal. That's what I'm saying. So, but I'm not going to say there's necessarily only one right answer. I mean, kind of, surprise me if you have another perspective on it. Kind of curious to read it. So B, C, D, you'll try those. So again, let me have you guys work through this. So I'll work out the answer key as well so you guys can see it. And that's what we'll do for this class. So, and then we'll play a game on Tuesday. And I'm not saying any specific homework because I know there's a lot going on. I know it's Halloween. If you want to enjoy Halloween, college apps, So I'm going to work out the answer key, scan it, make sure you guys have access to it, and ask questions. I'll just be sitting down at one of the tables.